And welcome back. Today we are doing Lesson 13, Session 3, Develop Graphing a Table of Equivalent Ratios. So you need to open your book to page 291. Yesterday we talked about how to compare different ratios and how to make an equivalent ratio, whether you were using multiplication, addition, whether you were modeling with pictures or using a rate table. So today we're going to continue, and once we've developed our table, then we are going to learn how to graph it. We talked a little bit about how those the ratios represent the different coordinates and which is the x and which is the y. So we're going to look a little more in depth as to that. So here's the story. We're going to read it and try to solve the problem below. A streaming music channel always plays the same ratio of pop songs to hip-hop songs. The point on the graph shows the number of hip-hop songs played for every 3 pop songs. Based on the relationship in the graph, how many hip-hop songs does the channel play for every 12 pop songs? So this is a good way when we use a graph that we can look and see whether we have a proportional relationship. So let's go back to the beginning. What are they asking us? What are they comparing? And the first thing I would think about is they are streaming music, and they always play the same ratio of pop songs to hip hop. So I'm going to remember it's pop to hip hop. And the point in the graph shows the number of hip hop songs played for every 3 pop songs. Based on the relationship in the graph, how many hip hop songs does the channel play for every 12 pop songs? So I want you to stop the video and see if you can figure that out. You might want to look very carefully here at the 3-to-2 ratio. 3 is my number of pop songs, so how many hip hop? Go ahead and stop and see if you can solve this problem. Okay, so if you're back, you notice that the ordered pair was 3-to-2, meaning my pop songs was my X and my hip hop was my Y. I could have done a picture and done 1, 2, 3 pop, and I have 2 hip hop. And if I wanted to do this until I had 12 pop songs. So I'm going to draw my model. It's an easy visual representation of this ratio. And it's easy to see that with the music channel plays 8 hip-hop songs. 1, 2, 3, 4, 5, 6, 7, 8 hip-hop songs for every 12 pop songs. For every, there's that term, for every 8 hip-hop, they play 12 pop songs. So I could have said, or I could say that ratio, again, is 12 to 8. If I wanted to do that on a table or a double number line, let's do this. If I had a double number line, and this is my pop songs, and this is my hip hop, I'd start with 0 and 0. If I had 3 pop, I have 2 hip hop. So 6 pop would be 4 hip hop. 9 pop would be 6 hip hop. And therefore 12 would be 8. For every 12 pop songs they play, 8 hip hop songs. So you can see how that's represented in both a graph, the model, the picture, and in the double number line. So if you turn the page to the next page, here is a model. We have a rate table. You can make a table of equivalent ratios from the given ordered pair. Remember, our ordered pair was 3 to 2. I have 3 pop songs. Notice they wrote that in blue because those two match. 2 hip hop songs. 3 pop, 2 hip hop. So I could do a vertical table like this. I could do a horizontal table like I think we did yesterday. I could do 3 to 2. I could do 6 to 4. So we have the horizontal table or a vertical table. This is first column is always my X, just like that was my X, and this is my Y. And that's going to be important to know as we go on to graph our relationship. Notice that each time they added 3, added 3, added 3, and with the hip hop songs, for every time they added 2, every time they added 3 on the other side. I wonder what 12 would be. Well, you already know the answer would be 8. Now, I want you to think about something, though. We talked a little bit yesterday about how I could use these numbers and add or multiply or divide and still find my relationship. So let's say I wanted to know how many hip-hop songs would there be played for 15 pop songs. Well, I know with 6, there's 4, and with 9, there's 6. So in 15, if I had 15 pop songs, I would have 10 hip-hop songs. So be looking at your relationships of your table, whether you're adding, subtracting, multiplying, dividing, to find an equivalent ratio. Now notice, now we've got the coordinates, over 3, up 2, over 6, up 4. And notice the red is my hip hop and my blue is my pop songs. Pop songs are here. It's my X coordinate. And if you will go on to the next page, how does the graph in the problem show that the ratio of pop songs to hip hop songs is 3 to 2? Well, the graph shows the number of pop songs on the x-axis and the number of hip-hop songs on the y-axis. So the point 3, 2 represents 3 pop songs and 2 hip-hop songs. So 3, 2 represents a coordinate of 3, 2, and that 3 is my x-axis. Oh, that's an x-axis. Remember, my x-axis is this one right here, and this is my y. So here's my x, and here's my y. If you look at the table in the first model it and the graph in the second model it, how is the addition pattern in the graph related to the addition pattern in the table? And aren't both patterns show adding equal groups of 3 pop songs and 2 hip-hop songs to every equivalent ratio? You do not have to write that down. How many hip-hop songs does the streaming music channel play for every 12 pop songs? And we knew the answer was 8. You can write that one down. And then it says plot a point on the graph to model this relationship. I don't know if you have a graph there or not, so we're just going to keep on moving on. How can you use a point on the graph to find another point that represents an equivalent ratio? So I do want you to answer this. How could I look at that graph and figure out something that they haven't already told me? Why don't you take a minute and write that down? You could start at the point, move right the same number of units as the x-coordinate, and up the same number of units as the y-coordinate. This is the same as combining 2 equal groups of the quantity and the ratio. So it shows me back here Every time I moved over 3, up 2, over 3, up 2. So I moved the x over the same amount each time and my y up the same amount each time. And I did want to point out that with this is a constant rate of increase. I'm going to erase these pencil or marks I got here. And if I want you to look at this picture, notice that if I were to draw a line from 0, I don't know if I can do it straight, I have a straight line. I have a constant rate of increase. It's increasing at the same amount every time. So this is a constant rate. And that tells me that this is proportional. So I have a constant rate of increase. It's proportional, and that means I have equivalent ratios. Okay, let's go back to this. And how could you use ordered pairs and multiplication to find equivalent ratios? If an ordered pair represents a ratio and you multiply both coordinates by the same number, you'll find the equivalent ratio. So for instance, if I had a 2, 3, and I multiplied both of these by, let's say, 3 times 3 times 3, then I get a 6 to 9. These are equivalent. I've increased them by the same amount, and think back to what the picture looks like and why that works. And you are actually going to do for homework for me. Let me double check here. You are going to do for homework for me page 296. And let me make sure that's it. But we are going to stop the video. We are finished with session 3. And I will have written on your directions as to what pages you need to do for your homework assignment. So hopefully you get all this done. Let me know if you have any questions.